안녕하세요. 3분 과학입니다. 오늘은 우리가 매일 느끼는 관성의 신비와 그 숨겨진 힘에 대해 탐구해 보겠습니다. 다양한 일상 속 예시와 우주에서의 놀라운 변화까지 끝까지 함께 하시며 흥미로운 사실들을 알아보세요. Inertia, the mysterious force that keeps us moving. But why? Inertia is a fundamental concept in physics that often goes unnoticed in our daily lives. It is the property of matter to resist changes in its state of motion. Simply put, an object at rest tends to stay at rest, and an object in motion continues to move at a constant velocity unless acted upon by an external force. This principle was first articulated by Sir Isaac Newton in his first law of motion, which states that the natural state of an object is to maintain its current state, whether it's at rest or in uniform motion. You might wonder why this resistance to change is essential. Imagine sitting in a moving car that suddenly stops. Your body lurches forward, and that's inertia at work. Your body wants to keep moving at the same speed as the car was, showcasing how inertia affects us directly. Inertia is proportional to mass. The more massive an object is, the greater its inertia. That's why it's much more challenging to push a heavy boulder than a small pebble, because the boulder has more inertia resisting your effort. Inertia isn't just limited to objects on Earth. It also plays a significant role in the cosmos. For instance, celestial bodies like planets and stars travel through the vacuum of space with remarkable speed, maintaining their motion due to inertia. When a spacecraft is launched, it relies on inertia to travel vast distances without using constant propulsion. Once it reaches a certain velocity, it can coast through the emptiness of space thanks to inertia. Moreover, inertia has practical applications in engineering and safety designs. Seatbelts in cars are designed to counteract the effects of inertia during sudden stops or collisions, keeping passengers safe by preventing them from continuing forward with the vehicle. Understanding inertia provides insight into not just how objects move, but also how we interact with them. It underlines the interconnectedness of motion and the forces that govern it, reminding us that the cosmos is a harmonious dance of inertia and motion. So next time you're in a moving vehicle or watching the stars, think about the hidden force of inertia that keeps everything moving in a beautifully complex universe. Everyday examples of inertia. Can you spot them all? Inertia is everywhere around us, and it plays a crucial role in our daily lives, often without us even realizing it. Let's dive into some everyday examples of inertia and uncover how this mysterious force impacts our world. First, think about when you're riding in a car. When the driver suddenly hits the brakes, your body lurches forward. That's inertia in action. Your body wants to keep moving at the same speed the car was going, and it takes the seatbelt or the dashboard to stop it. This is a clear demonstration of Newton's first law of motion, which states that an object in motion will stay in motion unless acted upon by an external force. Next time you're on a bus or a train, notice how passengers sway back and forth when the vehicle accelerates or decelerates. When the bus speeds up, those standing or sitting without support might feel a pull backward, and when it slows down, they might feel a push forward. This is inertia influencing their bodies as they resist the change in motion. Now, consider a simple game of basketball. When a player throws the ball, it follows a certain path dictated by its initial velocity. Once in the air, the ball will continue to move in that direction until gravity and air resistance act on it. Here, we see inertia keeping the ball in its state of motion until external forces intervene. Even straightening up a stack of books demonstrates inertia. If you suddenly pull a book from the bottom of the stack, the books above it might shift but remain in place momentarily due to their inertia. This is why careful movement is crucial when dealing with stacked objects. Let's not forget the classic example of a tablecloth trick. With a swift pull, the cloth can be yanked from under the dishes, leaving them in place. This works because the inertia of the dishes keeps them stationary while the cloth is removed. Lastly, think about sports like football or soccer. When a player kicks a ball, the ball doesn't stop immediately after the kick. It continues to roll until friction from the ground or another player acts on it. This is inertia keeping the ball in motion after being set in motion by the player's kick. In conclusion, inertia surrounds us in the simplest of actions every day. From riding in vehicles to playing sports, understanding inertia helps us grasp how forces interact with our world. So next time you notice these occurrences, remember, it's all about inertia at work. The hidden impacts of inertia in space. What happens when motion changes? When we think about inertia, we often visualize it in our everyday lives, like when our car suddenly stops and our bodies lurch forward. But what happens when we take this concept into the vastness of space? Inertia plays a critical role in the behavior of celestial bodies and spacecraft, fundamentally influencing their motion. In space, the absence of friction and air resistance means that once an object is in motion, it will continue to move indefinitely unless acted upon by another force. This principle can be observed with satellites orbiting Earth. They are in a constant state of free fall, continually falling towards the planet due to gravity, while also moving forward at a high speed. The balance between these two forces keeps them in a stable orbit, a perfect demonstration of inertia at work. But what if a spacecraft needs to change its trajectory? The inertia of the spacecraft must be overcome to alter its motion. This is where propulsion systems come into play. When a rocket fires its engines, it expels gas in one direction, which generates thrust in the opposite direction, allowing the spacecraft to change its velocity and direction. This is a practical application of Newton's third law. For every action, there is an equal and opposite reaction. In deeper space, the impacts of inertia become even more fascinating. Consider a hypothetical scenario involving a spacecraft traveling to one of the outer planets. Once it reaches a certain speed, it may use gravitational assists, or slingshots, around planets to conserve fuel. By using the gravity of a nearby planet, the spacecraft can gain additional speed without expending extra energy, demonstrating a clever manipulation of inertia. However, inertia in space is not without its challenges. Astronauts and equipment on board a spacecraft experience microgravity, which can lead to a variety of physiological effects. The human body is accustomed to the constant pull of Earth's gravity, and in microgravity, the sensations of inertia and motion can become disorienting. This is why astronauts undergo extensive training to adapt to these conditions before embarking on their missions. In summary, the impacts of inertia in space are profound and complex, affecting everything from the orbits of planets to the design and operation of spacecraft. Understanding these hidden forces not only deepens our knowledge of physics, but also enhances our ability to explore the universe safely and effectively. 영상 시청해주셔서 감사합니다. 관성의 신비를 함께 탐구하며 유익한 시간을 가지셨길 바랍니다. 더 많은 과학 이야기를 원하신다면 구독과 좋아요를 눌러주세요. 다음 영상에서 만나요.